let's do this question. Part A is this. Let's quickly check how. My transition matrix, my transition diagram was this, like this. J and P, and I had 80% here and 20% here, 20% here, and from peak to peak was what, 75%, and peak to Jill is 25%. So that was the diagram, right? Now Ethan, when I have two pizza shops, I create two columns and two rows with their names. I start with my column. It says, this was a weekly or what? This was, yeah, weekly. So this is current week, and this is next week. Next week. So 80% of people who have eaten at Jill's this week will return back to Jill's. Current week Jill's, next week Jill's. So JJ will be 0.8. Rest 20 will go to Pete. So Jill to Pete, 20. They add up to 1. So that means I'm fine. Similarly here, Peter to Peter is 75%. Peter to Peter is 75%. And remaining is how much? Because it's 100%, 25%. So they add up to 1 again. So that's part A. If this is not right, the question is gone for a toss. So you need to interpret the diagram into transition matrix, and at times you might not be that lucky to get this diagram as well. It will be just plain words, right? So you should be equipped to either do a diagram or transition matrix. 90% of the case they'll ask you to do transition matrix because diagram doesn't make sense, because this will drive the question forward. Okay? Now, next one. This one is clear? Transition matrix is clear? Now that was part A. Part B says, initially 400 eats at Jill's and 400 eats at Pete's. Write down the column matrix S0. Eating at Jill's, eating at Pete. 400, 400. That's the column matrix, my starting point. That's the answer for part B. Now I know my formulas. There are two formulas. One is Sn plus 1 equals to T times Sn. And the other one is Sn equals to T raised to the power of n times S0. This is called the next term formula. And this is called the nth term formula. Let's see what he's asking in part C. How many do you expect would go to Jill's next week and how many to Pete? Next week, so he's asking me S1 after the end of first week. So my S1 is, I can use this formula straight away. I can use any. And I say T raised to the power T times S0. I use this formula here. I've got T, I've got S0. I multiply both of them and I get a column matrix on CAS. That, if that is an approximated, if that's a decimal value, approximated, because he's exactly asked you for the next week. All good, Danu? So far so good, right? Part D of the question says, how many do you expect to go after 5 weeks? So I am after S5. So there is one way, Ethan, is that I keep going S1, S2, S3, S4, S5. Too much waste of time. I directly use this formula. T raised to the power of 5. We define T in your CAS. Time raised to the power of 5 times S0. And when you solve that, you will get a value. Whatever value you get, you might get a decimal value. You approximate that value. So that, because number of people can't be in decimals. right? Oh, good. So far with me, you understood that, right? Now, how you play around the CAS is your problem, right? You can still do it. More you practice, you'll get used to it. But at concept level, what you need to do is very important. Because if you know how to use CAS, but you don't know this, I mean, this is like a double-edged sword, right? I mean, you need to handle it carefully. Now, the last question is where I don't know why Dani was stuck. It says in long term. Long term, tell me how many will end up eating at Jill's and how many will end up eating at Pete. So, Michelle, when we say long term, we really need to throw some large values of n. So, if I were you, probably I would find a S30 and then I'll try to find an S35. Or if you want to find an S50, there's no limit to it. It's your problem, it's your choice. S50, 51, 52, use this formula. So if I were to find S50, I'll say S50 equals to t raised to the power of 50 times S0, and I'll find S51. I'll find the two consecutive, T51 times S0, and then I'll see what I'll observe is that the numbers won't change much. And whatever those numbers are, I approximate those values and I plug the answers in. What was the answer, by the way, for the long term? I mean, what values did you get eventually? You would have taken a different n, but then eventually the values would still be the same. What was that nth term answer that you got?
356 and 444.
None did you get that? Yeah. Now you plug in S5 matrix T, and it says today, and it says this is what Crispies and Crunchies, and you had Crispies and Crunchies here, and this is tomorrow. And the transition matrix goes like this. It says 0.42, 0.56, 0.58, and 0.44. Now, it says on Monday, 25% students ate Crispies. My S0 on Monday is my starting point, is 25%, right? So that means, let's say out of 100, 25% is 25 students, right? So how many actually ate the Crunchies? So if this was Crispies, how many ate Crunchies on Monday when 25% ate Crispies? Come on. Tell me. 75, right? Come on. Why are we so silent today? Is that not my starting point? This was Monday. And the question is, what percentage of students ate Crunchies on Tuesday? Tuesday, how many ate Crunchies? If today is Monday, and that's my starting point, how will I evaluate how many students ate Crunchies and Crispies on the very next day, which is tomorrow? If Monday is today, tomorrow is Tuesday. And how do I calculate tomorrow? I need to calculate S1. So S1 is at the end of Monday. That means, sorry, S1 is tomorrow. If S0 is Monday, which is today, S1 is Tuesday. And what is S1? T times S0. If you now multiply these two, you will get a matrix, something with Crispies and Crunchies here. And whatever you get here will be your answer. So in question, if they would have given you something like this, Monday, Tuesday. Then you would have got it. Then you would have said, okay, this is today, this is future. He's asking for future. So let me calculate this one. But they're not that straightforward. They'll not say you. They'll say today and tomorrow. Can you tell me what's the values that we've got here? What's the values that we've got here? Can anyone work out?
52.5 and 47.5.
52.5 and
47.5.
what's the answer here? You have 47.5 here? Yeah, for A, right? Now, this is Tuesday. Now, I go a step further down. I ask you, can you tell me how many will eat Crispies on Wednesday? What will you do? Tell me, what will you do?
S2.
You find S2, no? Because now your today is this. Tuesday becomes your today. And Wednesday becomes the tomorrow. So you will find S2. So in the question, you could be fudged in such a way that they'll give you something like this, and they say on Monday, 25% eat Crispies. Can you tell me how many will eat Crunchies on a Saturday? Then you say, okay, Monday is S0, Tuesday is S1, Wednesday is S2, Thursday is S3, Friday is S4, Saturday is S6. So then you simply find S6 is t raised to 6 times S0. And then you'll get your answer. Did you get it where the trick is? Right? So be careful, right? Be careful. Question number 10, the very next question, exam style. Expect this in the exam, right? They won't be asking you straightforward questions, I tell you. The question goes like this. A factory employs the same number of workers each day. This line is very important. The number of people that are employed every day are same. They don't change, right? Let's say they've employed X and Y people because there are two machines, right? Right? Now it says workers are allocated on either machine A or machine B. And there's a transition matrix that they're given. The transition matrix is A, B, A, B, which is 0.32, 0.68, 0.16, 0.84. And says the workers are allocated in different. Now, transition matrix is given to you. It says the workers may be allocated to work on different machines from day to day based on this transition matrix. Machine A has 72 workers working on it. Machine A has 72 workers working on it. Each day, the number of workers machine B will be. So we need to find machine B. Now, I'll give this book back to you. Now, what is 72? What is 72? And probably, what is 0.84? Let's say I have this and I get this. Basically, I just need to solve this. Just need to solve this. 0.68 of 72 plus 0.84 of number of workers on machine B will be the total number of machine B. Let's understand this. I am asked to find on a given day how many are there sitting on B, correct? On a given day, how many will be sitting on B? How do I tell how many will be sitting on B? If this is today and this is, let's say, tomorrow, this tells me tomorrow how many will be sitting on B at this point in time. Anyone sitting on A, anyone who's, if there are 72 on A, 68% of those will go to B, correct? So that means on B I'll have 68% of 72 on a given day, and on B 84% are returning back. So I will add 84% of Y as well. So what I'm trying to say is let Y be the total workers on B, total on B, and this is total on A. So on B, how many workers will be there? 68% coming from A and 84% coming from B. B was Y. A was given to me, so I have calculated 68% of 72 and 80%, 84% of B. Now B is Y. I add them and that'll be Y itself, the total number. I solve it and I get the answer. I solve it and I get the answer. Now whatever that answer is. Then did you get this point, this equation or not? Very, very important. At a given point in B, you have people who were sitting on A moved to B, and people who are on B remained at B. Just added them and said